Okay, I don't know how well this one will show up, but what I'm going to demonstrate is how to calculate the information for a 555 timer circuit. So what I've got right now is a display up here that goes ahead and shows a 555 timer circuit, and it wants us to find the period, frequency, and duty cycle of this circuit. It tells us that RA equals 390 ohms, RB equals 180 ohms, and the capacitor is 6.8 microfarads. So what we would go ahead and do, using my normal guess technique, that's the technique that I've taught before. The first letter is G for givens, and the givens that I have are those three that I just named off. RA equals 390 ohms, RB equals 180 ohms, and C equals 6.8 microfarads. U, or my unknowns, I like to go ahead and teach just the basic equations for the 555 timer, so I have a couple more unknowns than the three that they listed. I obviously need my time total, I need my frequency, and I need my duty cycle. I also go ahead and solve for time high and time low, and then just use all the other equations we already know to solve for the rest of these. So I'm going to put time high and time low. Then the next letter is my equations. So for this, I need to go ahead and have my 555 timer equation. So I've got time high equals 0.693 times RA plus RB times my capacitor. Time low equals 0.693 times RB times my capacitor. Then I still have my equations from before. I know that time total is going to equal time high plus time low. I know that my frequency is going to equal 1 over time. And I know that my duty cycle equals time high over time total times 100%. Then I put my substitute and solve steps together instead of doing them separately. So I'm going to solve for my time high and my time low first. So time high equals 0.693 times resistor A is 390 ohms plus 180 ohms for resistor B times my capacitor, which I put back in my base units. So it's 6.8 microfarads. That'd be 0.00000068 farads. And if I punch that all into a calculator, so if I go ahead and take 0.693 times 390 plus 180 is going to go ahead and give me 570 times 0.000068. I come up with point, it equals 0.00266, and I'm going to round here to a 9 right there. It was 686068. And I could go ahead and put my label on there, that is time, so it's in seconds. I'm going to bring that back over to my unknown list. So I know that my time high is going to equal, I'm going to convert it into SI prefix, 2.69 milliseconds. Time low equals 0.693 times 180 ohms times our 0.000068 farads. Once again, plug it into the calculator. So 0.693 times 180 times 0.000068 is going to go ahead and give me 0.0008 for 8 seconds. Once again, I could go ahead and convert that to microseconds. I'm going to go ahead and leave it in milliseconds. That way it kind of matches up with the time high I already have. So we have 0.8 for 8 milliseconds. Now that I have both of those, I can add them together to get my time total. I probably don't need to show that step if I just take 0.0, or if I can do it in milliseconds. 2.69 plus 0.848 milliseconds gives me a total time of 3.538 milliseconds. Now that I have both of those, I can go ahead and solve for my frequency, my duty cycle. I can solve for both of those now. So my frequency is just 1 over my time, which is 3.538 milliseconds. Or I'd go ahead and convert that to 1 divided by, I've got to go back to my base units, 0.0035338 seconds. So once again, I plug that into the calculator. 1 divided by 0.0035385. My bad, 38 seconds equals 282.65 hertz. So I'm going to put that right over here. 282.65 hertz. Once again, I did round that off a little bit. For my duty cycle, I'm going to see if I have enough space up here to go ahead and write that. I might have to adjust the camera in a little bit for you to see my math. So duty cycle equals time high, which is our 2.69 milliseconds. Now I could leave this in milliseconds, since they're both in milliseconds for my time high and time total. I can leave it in milliseconds. However, if that confuses you, you can also take it back to your base units. The reason I can go ahead and leave it in milliseconds is because when I divide milliseconds by milliseconds, the milliseconds actually cancel out. When you divide those, they cancel out. So if I go ahead and take 2.69 divided by 3.538, I end up with 0.76 times my 100%, and I come up with an answer of 76% duty cycle. That is how I would go ahead and solve a 555 timer circuit. Now I'll make sure that the camera caught all the work and zoom in on it a little bit so you can see it a little better. So right there's my list of givens and unknowns. As I come across the board, right there's my equations at the top, there's my substitute and solve, and then I've got my duty cycle up there in the top right hand corner. So that should go ahead and show all of my work for this problem. Once again, this was the circuit that I was dealing with, and we can see that I've got RA, RB, and C over on the left hand side. Give you a little more time to look at the work if you'd like to.